Hi everyone, welcome to Unit 6. We will be using the packet that starts with Guess the Mystery Proportion. Before we do that though, we would like you to go ahead and do this warm-up. You can find it in Canvas, print it, or download it, complete it on the paper or a separate sheet, whatever is easiest for you. So go ahead and do 1 through 6, pause this video, and then unpause to check the answers. This should be a review of Unit 5. So in Unit 5, we spent a lot of time talking about population, parameter, sample, and statistic. So hopefully you were able to identify that. And the symbols are really important. Remember, P for population proportion, and then P hat for sample proportion. And then this warm-up just kind of reminds you of some of the stuff we learned before. We do have some evidence that more than 13% of the pennies are from pre-1982 copper because her sample was higher than that parameter. But that could just be chance, or the container really could have a larger percent. And so here's a partial sampling distribution of 100 samples. And so we look at this one specific value, 22%, and that means that in a sample of 50 pennies, 22% of those pennies were copper. If we're investigating Jenna's claim here, her specific sample is the one at 22%. We will look at 22% or higher, and that's where the 4 out of 100 comes from in number 5, which is a pretty small chance. That's only 4%. Our barrier is usually about 5%, so it is less. We consider that unlikely enough to give us evidence against the claim and say that the percent of pennies really should be higher than 13.2 in her container. So I'll just zoom out a little bit, make sure you got this, and then we'll move on to our activity. So like I said a few minutes ago, we're starting with the packet that says Guess the Mystery Proportion. Just for a little background information, in class, I have a jar full of beads. Some beads are red, some beads are black. Whenever a student does something right, I like to give them a bead, and use chance, of course. If the bead is red, they win a prize. If the bead isn't red, it's black, they don't win a prize. And so the thing right now is that you guys do not know what proportion of my jar is red. So you guys are wondering, what's the likelihood that I'll get a prize every time I draw a bead out of this jar? And so what we can do is, I don't want to count all the beads, and you don't want to count all the beads. What we're going to do instead is we are going to take a sample of beads from the jar and use the sample to estimate the proportion that are red. So one thing is that if you guys are in class, you'll get your own sample. If you're not in class though, and we're at our own homes or we're absent from class, then I'll just tell you, let's say I gave you a sample of 20 beads and 7 of them were red. So I'm going to say you had 7 red beads out of 20. If you're in class, you'll get your own. If you're not, I want you to use 7. And what I want you to do is use 7 as your best guess for what the true proportion is. I want you to work through questions 1 through 7, and then you're going to stop. We'll debrief, and then you'll finish the rest of the activity. So whoever is the closest to the percent of red beads in the jar will get a prize, and you have to be the closest and have the smallest interval. So you're going to give a little estimate, plus or minus, and I want that estimate to be smallest to get the interval. So give it a pause, work through the activity, come back to go over the answers. All right, so let's see how you guys did on this activity. First, anything that is purple highlighted there is because if you were in class, you might have had a different sample with different proportions. So we're just using the 7 out of 20 as the example, but all of the debrief notes should be about the same. So as a quick reminder, you did not know what the true proportion of red beads in the jar is, so you don't know your chances right now of winning a prize when you pull beet out of the jar, but we use the sample as our best guess. So we call that the point estimate, and the point estimate comes from the sample. And so that is our best guess at the true value. So we're estimating it. That's where that word comes from. And as you know, anything from a sample is called a statistic. We went over that in the warm-up. And so that is from Unit 5. And that is what those two are interchangeable. We're going to use those interchangeably. So a couple more things to talk about. Don't forget, parameter describes population, statistics describes the sample. Usually the parameter is unknown now. We knew it maybe in Unit 5, but typically the parameter is what we're trying to estimate with the statistic. And so that is always going to have the word true in it and be unknown. All right, let's keep moving. So you guys could have all written different things for 3, 4, and 5. It was your job to try to get a small margin of error that would capture the true value, but be precise. So someone could have said that their margin of error was 0.5 and they add or subtract 0.5, and you're really confident that it's going to capture the true value, but that's not really very practical. So a couple things about this. This is called, whenever you have a margin of error, it adds or subtracts to your point estimate and gives you a range of plausible values. And so we have a little formula for it. It's point estimate plus or minus your margin of error will equal the interval from A to B. So you can use either form, point estimate plus or minus margin of error, or the lower to the upper, the interval. And so number 5, how confident were you? I just made up, I was about 80% confident. We call that the capture rate, confidence level, which you'll explore a little bit more about on the next page. And then that tells us how often we think our interval will capture the true value. Number 6, one of the groups got 0.27 to 0.33. What was their point estimate and what was their margin of error? So you just have to think about that. Hopefully you got the answer. The point estimate is if you have the interval from A to B, then the point estimate equals the middle. So we can just average A and B. A plus B over 2. The margin of error is kind of like half the width, so we can do B minus A over 2. You don't want to get too hung up on formulas like that, because there's a lot of other formulas we're going to learn. You just want to think logically about if this interval goes from 3 to 5, the middle is 4, and the margin of error is 1. So just think logically to get that answer. And then this last part, one group claims the true proportion is 25%. Does your interval support this? The answers will vary here, so not all intervals will. And so what I want to write is yes if the interval includes 0.25, because it lists it as a plausible value. And then we'll say no if the interval doesn't include 0.25, because your interval would mean that that's not a plausible value. What I want to write in red is if the interval gives a set of plausible, can spell, values. So that is basically what we're looking at with the confidence interval. Now there's a lot more to it that I want you to explore on the next activity. And so I'm going to go ahead and just show you that so you can get started. Here I want you to use this applet to explore some more technical pieces of a confidence interval. Of course, the sample size is going to play a factor and how confident we are. That 80% I just made up over here, and you guys just made up. We say that kind of stuff all the time, like, oh, I'm 90% sure about my answer. But in statistics, that percentage is going to mean something, and it's going to be mathematical. There's going to be a reason behind it. So I want you to use this applet to play around with some different things that affect the confidence level and the sample size, and the margin of error and all of that. And then you can unpause the video to check your work. All right, again, I just have an example of one that I did myself. So the answers will vary on question 3 and 5. But question 1 is right from there. And so I just want, this is definition of confidence level. And another way that we can describe that is the capture rate. And so we will look at that on number 5. For number 4, that dot in the middle was the average from the sample, which is another, remember, that's our point estimate or our statistic. Those are synonyms. So that value was X bar from the sample. That's the point estimate or the statistic. Everyone should get probably different things on number 5, but they should be close to 80%, which I like to call the capture rate. And that is your confidence level. So when we say I'm 95% confident, then we mean 95% of the intervals will capture the true value. And hopefully on 6 and 7, you were able to just see some relationships so that you could fill in number 8. I'm just going to write a note at the bottom. As your confidence level increases, your margin of error increases, and as your sample size increases, your margin of error will decrease. So that should make sense. As we talked about before, the more confident I am, the wider an interval I'll have because I'll be more likely to be correct. So I could be 100% confident it will rain between 0 and 1,000,000 inches tomorrow, but that is a pretty wide margin of error, and so it's not that useful. And then your sample size increases, variability decreases, as we learned in Unit 5, so hopefully that helps you think about the relationship for confidence intervals too. Okay, here's the note. Here are the notes for today. So I just kind of summarized what we had written in red on the activity. So I'm just going to zoom out a little so you guys can pause and copy it all down. And then we will move on to our check your understanding. All right, so one thing you'll need in your check your understanding is definitely these interpretations. So anything I highlighted is something that you would replace with the context. And if you try to check your understanding now, you'll see a few examples and you can use these interpretations to help. And then I will show you the answer key and you can see how it's done officially and correct any mistakes that you've made. All right, so just a quick, let's talk about this interpretation. So you basically need to replace the percent with whatever the percent is here. And then we have the interval from blank to blank. And so we use those. And then we always say it captures the true. And then we just use proportion of US adults who would currently answer nitrogen. And so I have proportion who would currently answer nitrogen. I just added the population in there because it should be a little bit more specific so that it includes all the information. And then it's really key that we say like who would, not who did. So it's who would answer. We already know who did from the sample. It was 20% of them, but not who would overall in the population. And then remember, we have A plus B over 2 and B minus A over 2 for our point estimate and margin of error. And I could rewrite this as 0.2 plus or minus 0.025, and that's where the 0.175 and the 0.225 came from. And then here, I would just say, like 25% is not plausible according to our interval. So that means we have evidence against it. Here, I'll do the highlight thing again. We always say in repeated sampling of size, and then whatever the sample size is, 25. I got that from right there. Then approximately the confidence level, 90% of all confidence intervals created will capture the true. And then the last thing is mean GPA for all students at her school. And I just got that exactly from right there. We're just copying those words. And then here we hopefully remember as C increases, margin of error increases. As N increases, margin of error decreases. This last note is that one potential source of bias in Ellery study that is not accounted for. People could be lying, and the margin of error will not account for that. Margin of error is only affected by C and N, which we can see right here, C and N. Okay, so that's so fun. I love confidence intervals. Hopefully you guys will too. We'll keep practicing with these, and I will see you next time. Thank you so much. Have a great day.